Hello everyone, welcome to today's class. This is teacher Simon taking you through Cambridge IGCSE Extended Mathematics for October-November 2024 for questions from 15 to 23. Question 15. At the start of an experiment, there are 40,000 bacteria. The number of bacteria increases at a rate of 15% per hour. Calculate the number of bacteria after 3 hours. So for exponential increase and decrease, we use this formula, just like the one for compound interest. So n is equal to, let's say, n naught, then plus, this one is 1, plus r over 100, and then t. Now, this is exponential increase. If it is decrease, then we can put a minus here, okay? So here we shall have the 40,000, then into 1 plus 15 out of 100 after 3 hours, so that will be 3. Then we have 40,000, then times, this will be 1.15 cubed. So you put this in the calculator, 40,000 into 1.15, then cubed. So this one will give us 60835. 60835. Question 16. 75 people are asked if they have a car and if they have a job. The Venn diagram shows the results. And they are saying that a person is chosen at random from those who have a car. Find a probability that this person also has a job. So the probability here we are looking for, probability, is for a person is chosen at random from those who have a car. So we are choosing from here. This is our sample space. Okay. Now, find the probability that this person has a job. So that is the one in the middle here. Okay. They are choosing from the intersection region. So that means we are going to have number of those in C intersection J, then divide by number of those in C, because we are picking from those who have a car, not the universal set. So this is 51. Okay, we shall have 51, then we divide by, the total is 9 plus 51, and this one gives us 51 over 60. Yes, 51 over 60. 51 over 60. So you just write that, 51 over 60. Can it be simplified? Let's check. 51 divided by 60. Yes, 17 over 20, which is 0.85. So you can write n of them. You can write 17 over 20. You can write 51 over 60. You can also write 0.85. All are correct. Question 17. A, B, and C are points on the circumference of a circle with center O. DA and DC are tangents to the circle. Now, tangents which intersect outside the circle are always equal in length. Okay? AD is therefore equal to DC. Then the angle between the radius and the tangent is always 90 degrees. So this one is 90 and also this one is 90. Okay. Then angle ABC is equal to 64. Then work out the value of x. Now I need to first get angle at the center, which is going to be twice that 64, because angle, let me write everything here. Angle AOC is going to be equal to 2 times 64, which is equal to 128. What is the reason? Angle at the center is twice angle at the circumference. Twice angle at the circumference. Just like that. Then after that, there are two ways you can do this. You can consider the whole of this as a quadrilateral. Okay, this is 90. We have this one here, then we also have this one here, and then this one here. Okay, but since already we have 90 here and we also have 90 here, That is 180. So we are remaining with 180 to make 360, right? So that means this x here plus this angle here should give you 180. Okay? So we don't need to waste time. We just say that x there is going to be equal to 180, then minus the 128. Then this one will give us 52. Question 18, part A, we are given the universal set that has numbers 8 times 10 to the power negative 1. Then we have 0.8 recurring. I want you to see this 8 here has gotten a dot on it. You see? It has a dot on it. So it is a recurring number. And that is the same as 8 over 9. Okay? Then, what else are they saying here? So we have 8%, then square root of 0.08. Then you're saying that A is the set whereby A ranges between 0.08 to 0.8, and then B is greater than 0.8, greater or equal. Now, 8 times 10 to the power negative 1 is the same as 0.8. Okay? Then this one here is 0.888 recurring. Okay? 8% is 0.08. And then this other one here, the square root. You can have the square root of 0.08. This one is going to give us 0.28284. 0.28284. And the rest of the figures. Okay? Now, in here, they are saying that A is between here. So it is greater than the 0.05, but less than or equal to 0.08. So 0.08 is inclusive. So, but it is also here, you see, and it's not 0.08, it is 0.8. And it is also in B. So that means that 0.8, which is 8 times 10 to the power negative, is the intersection. Now for B, we have to look for numbers which are greater or equal to 0.8. So this number here, the recurring decimal, is greater than 0.8. So I'll put it here 0.8 with a dot there. And then the square root of 0.08 is in this set for the values that range from 0.08 to 0.8. And of course, this one is less than the 0.888, okay? And then 8% is 0.08. It is not in this range here. They said greater than. You see that? Okay, they said greater than 0.08. So for it is below that. So that means 8% is outside. So we have that. Part B, shade the Venn diagram. Shade the region A union C, intersection B complement. Now, for such complicated stuff, what you do is to split this into two sets. So I have these ones here. We have A, B, and C. Then I shade A union C. We have now two sets, this one and this one here. So A union C, you get everything inside A and inside C. You shade them. So this is what we are going to have here. Then next, you go and shade B complement. Put all the sets in, okay? A, B, and C. Then we are going to shade B complement. So everything outside of B. So we can shade and we leave only B not shaded. So everything here shaded like that. Now for intersection, for A union C intersection B complement, okay, then we are going to, we pick we pick the common shaded regions, the common shaded regions. If it were union, then we just unite, just slide this into this, as simple as that. So here we are going to pick what is common shaded. So there is this, you see that region, then there is this one here, is also shaded, then there is this one here, is also shaded in both, so nowhere else. That means when we come to our graph here, when we come to our Venn diagram, we can now shade here. We are going to shade here, this region, shade it smartly. Then the next one is this one here, you also shade it, and then lastly this one for C only, you also shade it like that. So that is going to be your shaded diagram. Question 19. A solid is made from a cylinder and a hemisphere, both of radius 4.3. The cylinder has length 11.9. Part A. Calculate the volume of the solid. So volume of the solid, is going to be equal to, we get volume of the hemisphere, and then we add volume of a cylinder, because they are put together, volume of the cylinder. Then volume of a hemisphere is a half volume of a sphere. Volume of a sphere is given as 4/3 pi r cubed, and the radius is 4.3. Then you cube this one, then plus we have pi here, and volume of the cylinder is pi r squared, so r is 4.3, we square it, and then the h is 11.9. The volume of the cylinder is pi r squared h, because this cylinder is a prism, so every time you cut, you see this circular part, so that means the cross-sectional area is that of a circle. Then now times this length here, that's why it is pi r squared h. Okay, so that is that. Now we put everything in the calculator here. 0.5 times 4 pi over 3, then times 4.3, then cubed. That one will give us 166, and the rest of those figures. Okay, then I can actually put everything together. Okay, so I add on this other one here, which is pi, then times 4.3 squared, then times 11.9. So all of it together, I get 857 and the rest of those figures, but to three significant figures, I can write 858. Three significant figures, because this is a non-exact number. Part B, calculate the total surface area of the solid. So the total surface area, we draw the net. So total surface area, we have to look at all the areas of the surfaces. We shall have the curved surface area, of the hemisphere. Okay, of the hemisphere. Let me show you something here. So there is this curved surface area of the hemisphere. Since these two are stuck together, this area of the circle here, this one is gone. Okay, so we are not going to consider it. So we have the area of the curved surface, then we have this curved surface area of the cylinder. Okay, and if you have a cylinder like this, and then you cut here and you open it up, okay, what was the circumference here is now going to straighten like this, and then will give you this rectangle. You see that? But circumference of this circle here is given by 2 pi r. Then this one is our h here. So curved surface area is going to be 2 pi r h. Then there is also this circular part here. Now, we are going to have curved surface area of the hemisphere, then plus the curved surface area of the cylinder. Okay, and then we have the circular area. Okay, area of a circle. So circular area of a cylinder. We have seen it up there. So this one is pi r squared. All right, this one is 2 pi r h. Then this one here is a half of 2 pi r h. Now, yes, because no, it's not 2 pi. They must have given us something here. Yes, in the brackets we have the surface area of the sphere is this, so it's 4 pi r squared. So for the hemisphere it will be a half of it. Now we substitute. This will be, of course, a half of 4 is going to give us a 2, so 2 pi, then the r is 4.3 squared, then plus 2 pi, the r is 4.3, then times the 11.9, and then plus the other one is pi r, which is 4.3, then squared. And I can put each and everything in the calculator. Okay, so putting everything there, we can have 2 then pi times 4.3 squared. Then I add 2 pi then times 4.3 times 11.9, then plus pi times 4.3, I put it also in bracket, times 4.3, then squared. So all of it together, I get my answer like that. So if they say in terms of pi, then it will be like that. But changing this one to 3 significant figures, it will give us 496. So I write here 496 to 3 significant figures. Question 20. Find an expression for the nth term of this sequence. Now, when you look at this one here, these are powers of 7. Okay? Here, it is 7 power negative 1. Here, it is 7 power 0. 7 power 1, 7 power 2, 7 power 3, 7 power 4. Now, what we need to do, let us look at the positions. Okay, the positions of the terms n. So we have position 1, position 2, position 3, position 4, position 5, and then we can have the terms. So the terms here are 7 power negative 1, 7 power 0, 7 power 1, 7 power 2, 7 power 3. We also have 7 power 4. Now, look at how, because now they are powers of 7, then 7 is the constant here. Okay, so what is changing is the power of 7. Now, look at these positions, how they are connected to the powers. From 2 to 0, don't you think they subtracted a 2? From 3 to 1, don't you think they subtracted a 2? 4 to 2, the same. 5 to 3, the same. 6 to 4, the same. Even here, the same. So that means the nth term, they got 7, and then the power is the position of the term, then minus 2. So that has to be our answer here. The nth term is 7 power n minus 2. Alternatively, okay, I always give alternative approaches. So alternatively, you can see that every now and then they are multiplying by something. Okay, they are multiplying by 7, multiplying by 7. That is what we call a geometric sequence. So nth term is now going to be a power r into, the power is n minus 1, where r is the common ratio. We call it the common ratio. You get the preceding term divided by the preceding term. So the common ratio, you can get, let's say, the second term, okay, that's the preceding, divided by the first term. You can get the third term divided by the second term, the fourth term divided by the third term, like that. And then a here is the first term. So the first term is 1 over 7. The common ratio, you get 7 divided by 1, that is 7. So it is 7, then n minus 1. Then I simplify this. This 7 will be power negative 1. Then 7 here, power n minus 1. Now using rules of indices, we shall add these powers. So negative 1, then plus n minus 1. So you get 7 power n minus 2. Question 21, expand and simplify. So I need to expand this, the first two, then I multiply by this. Or you can begin with any you want. I can begin with these two, then I multiply by this. I can even begin with the first and the last, because multiplication is commutative. So I'll get x, the one in the first bracket has to multiply with everything in the second bracket. So I can split it like that. Then plus 3 has to also multiply with x plus 5. See that? Then here we have 2x plus 1. Open the brackets here, you get x squared plus 5x, then plus 3x, and then plus 15. Okay, then we shall get 2x plus 1. So this is simplified as x squared plus 8x, then plus 15. Okay, then 2x plus 1. Again, this x squared here has to multiply with 2x plus 1. Also, 8x has to multiply with 2x plus 1. The same with 15, with 2x plus 1. Now, here we shall get 2x cubed plus x squared. Then here 16x squared plus 8x. Then here 30x plus 15. Then when we simplify, we can get here 2x cubed. Then the squares, we have this and this. That is 17. So 17x squared. And then the x's, we are having 8 and 30. So we shall get 38 of x, then plus 15. Just like that. Question 22. A is the point 17,9 and B is the point 23,39. Find the equation of the perpendicular bisector of a line AB. Give your answer in the form y is equal to mx plus c. So suppose I have this line here. A perpendicular bisector always passes through the midpoint. So if this is my A, which is 17,9, and then this is my B, which is 23,39. Let me write it here. A perpendicular bisector always passes through the midpoint of a line segment. This is very important. Okay, now that means we need to get the midpoint of AB, which is going to be the average of the x coordinate and then the average of the y coordinates. So we shall have 17 plus 23, we divide by 2, then 9 plus 39, we divide by 2. So 17 plus 23, that is 40 divided by 2, that will be 20. And then 9 plus 39, that will be 48. Divide by 2, we get 24. Now we need to get the gradient of AB, M1. Okay, M1 is going to be, remember, it is change in y over change in x. So we shall have 39 minus 9 over 23 minus 17. Now 39 minus 9, that is 30, over 23 minus 17, that is 6. When we divide here, we get 5. Now, for us to get the equation of a line, we must get the gradient and also at least one point through which the line passes. But we know that for perpendicular lines, okay, M1 times M2 is equal to -1. The product of the gradients of the two perpendicular lines is always equal to -1. So that means our M2 is going to be equal to -1 over M1, which is 5. Okay, now that means we are going to use the equation of a straight line here, which says that y is equal to mx plus c. Now we are going to use the other coordinate. We got the midpoint 20, 24. So 24 here for y, and then this one is -1 over 5 as the gradient, and then x is 20, then plus c. So our mandate is to find the value of c. This one will be -4, then plus c. So when this one crosses, it will be 24 plus 4, which is equal to c, and then c becomes 28. So meaning the equation of the perpendicular bisector is going to be -1 over 5 of x, then plus 28. Question 23. The small box is mathematically similar to the large box. The volume of the large box is 72.8% greater than the volume of the small box. The small box has length 3.5 centimeters and the large box has length x centimeters. Find the value of x. Now volume, here we are having volume and length. So we should know that volume scale factor is always equal to the length scale factor cubed. Length scale factor cubed. Okay, why is it cubed? Volume is given in cubic units, and yet the side lengths are given in just a unit. You see that? Now, volume of the bigger one over volume of the smaller one is the one that is going to give us the scale factor, the volume scale factor. So, if the volume of the smaller one is V, okay, then volume of the bigger one is going to be V times, because it was increased by 72.8%. So I will have here 100, then plus the 72, it was increased by that percentage, then out of what? 100. You see that? Then we come this other side. Length of the large box is x, then divide by the corresponding side here, which is 3.5. So 3.5 here, then we cube it. So do you see that this v cancels with this one? And then 100 plus 72.8, that is 172.8. Divide by 100, we shall get 1.728. And then this way, we have x over 3.5. Since I'm looking for x, then I'll take the cube root on both sides. So cube root of 1.728 then shall be equal to x over 3.5. And then I will cross multiply. So meaning x is going to be 3.5 times the cube root of 1.728. So putting this in the calculator, what do we get? 3.5 then times this cube root of 1.728. So altogether is 21 over 5, which is 4.2. So we write our answer here as 4.2. So this has been it for this paper. Thank you so much for watching. May God bless you. If you find the content very helpful to you, kindly like, share, and even subscribe. See you in the next videos.